And we keep going. If the function f(x) is s to our n, and then that's even negative numbers integer, we can say they're always going to be the positive number. And then your graph will be all going to be above the x-axis, and all the y value is going to be all positive. And your domain will be, except for 0, is a real number, but your range will be the positive real number, but no 0 at all. Still, horizontal and vertical asymptote depends on the x and equals 0 and y equals 0. Then let's keep going with function. If the x to the power of fractions, which is 1 over n, then n is positive number. We could rewrite, this is an index law, by the way, a to the power of 1 over n, that means the square, it's not square, it's n root of the a. So a to the power of 1 over n to the power of n equal to a. If that's an even number, our graph will be looks like that. But if that's the odd number, positive, that will be looks like positive part and negative part. Perfect. Let's start with examples. I want to graphing those two first. So find the value of x, which is f(x) equal to gx. Okay, that means your intersection point. When f(x) equal to gx, that means x to the power of third, 1/3 equal to x to the power of 1, 2. Perfect. And then how we calculate it? Very simple. I show you. First thing first, both sides minus the x to the power half equal to 0. And I move the x to the 1/3 outside the bracket, 1 minus x to the power of x to the power of. Guess what? 1/6. Guess why? Because equal to 0. Think about it. If x 1/3 and times x to the 1/6, that actually equal to x to the power of half. That's index law here. So that's why I'm using the reverse the index law. Why I'm doing that? Because I really can say is when x equal to 0 and f(x) or gx equal to 0. And when x equal to, when 1 minus x to the power of 6 equal to 0, that means x to the 1 over 6 equal to 1, and x equal to, there's only 1 in here. Perfect. Does that make sense? Yeah. So when x equal to 1, f(x) or gx equal to 1 as well. So 1, 1. So we have 0, 0, and 1, 1. So these two are answer. Perfect. Now I'm going to sketching both graphs. Okay, now I'm going to make that happen with actually already graphing it beforehand. So square root x to the power half, and also 1 and 1. 1, 1, and 0. Perfect, 0. Okay, next one is you're going to be like that, and also like that. Perfect. So x to the power of third. There you go. Show the 1, 1, and 0, 0. And there you go. That's your graph for the both ones, f and gx. Now let me introduce the inverse of the power functions. Once we had inverse, if the n is all positive integer, then f(x) equal to x power n, and also slightly increasing for the real numbers. If x is all the 1-to-1 function, the inverse function also is all number function. if I want to prove that, well, please have a look at page 48 and 47, and then I'll give you ideas. All right, I only do question C in here maybe. Let's try to find out f r to r fx is equal to a to the power x subcubic. All right, first thing first, let's solve for inverse function. So let fx equal to y. So that means y equal to a to x cubic. And I switch the x and y, that's x equal to 8y cubic. Perfect, and then we keep going, and 8x over 8 equal to y cubic. And f negative x, that will be equal to both sides cubic root, so which is the x to the 8 equal to y. And if we simplify that, that'll be x to the 1/3 over 8 to the 1/3, and that actually equal to, because 8 to 1/3, by the way, this one, another algebra knowledge, is equal to 2, because 2 cubic equal to 8. All right, so just in case. So that means half, and x to the 1/3. Perfect. After that, you could rewrite as function -1. X can be a real number, and 2, the real number for range, and then f to the -1x equal to half x to the 1/3. Perfect. And let's try the question D then. That one as well, we could start with, because it's the 1 to the positive, okay? So we should do is f 1 to the positive infinity to r fx equal to 64x to the power 6. All right, and solve that one first. We know function of range will be start with 64 to the positive infinity. So range will be 64 to positive infinity. Therefore, f to the -1 domain is 64 to infinity. And your range will be 1 to infinity. Does that make sense? So you opposite them. Yeah. So we can rewrite as y equal to 64x to the power 6, and x equal to 64y to the power 6. That's the inverse, opposite, and y to the power 6 equal to x to the 64, and both sides gonna be 6 power of the root, so which is around like x to the 1/6 over 64 to the 1/6. All right, and that equal to y. So y equal to half, which is half 2 to the power of 6 equal to 64. That's 1/2 x to the power 1/6. If you write in this one, I'm not going to give you the full mark, because you remember this even number, you're also going to have the negative part. So you have to add in plus and minus. So, but also we know your domain is positive 64 to the infinity, 64 to the infinity, and range is positive infinity. So we actually can cancel out the negative, but you still have to show me, okay? So that's function -1, 64 to infinity. You have to show the domain to the range, and f -1x equal to half x to the power 1/6. Perfect. That's all about inverse function to solve, and with the domain and range. So I want you guys to remember that part as well. Okay, that's all the chapter 1. Hopefully you guys are understanding what we actually go through, functional notations. Please do some questions during this time. And yeah, and I will keep updating my videos recordings, and hopefully that makes sense for you guys, and hopefully that help you guys as well. Okay, all right, see you next time.